To make accurate inferences about the population, it is essential to draw a representative sample of the population. For example, to know the opinion of psychology students about a particular social issue. Of course, I have to collect the data from psychology students rather than students of other courses. Similarly, out of 100 students in a psychology class, if I collect data only from 5 students, the inferences drawn may not be accurate. So the question is, how many participants should be selected to achieve an adequate representation of the population? Estimation of sample size will help us to answer this question. In sample size estimation, 4 factors have to be considered. First factor is margin of error or confidence interval. It is a range of values that is likely to capture the true population parameter. For example, if a researcher says that the confidence interval of mean is 43 to 47, then it can be assumed that the population mean is likely to fall within this range. Confidence interval indicates about the precision of our measurement. Hence, broader the range, lesser the precision, and vice versa. The researcher can decide on what level of precision he or she wants. Second factor is confidence level. It indicates how much confident is the researcher that the population value will fall within the confidence interval which is already been set. Taking the above example, if a researcher says 95% confidence level, it means that out of 100 trials, 95 times the population mean will fall between 43 to 47. This is more accurate for a random sample. The other most commonly used confidence levels are 90% and 99%. Third factor is the population standard deviation, which is the variability of scores in a population distribution. Finally, the fourth factor is population size, which is the total number of units, for example, number of individuals in a population that the researcher is interested to study. The problem here is, what if the population size is not known? We don't have to worry about it because there are two formulas. One is to estimate the sample size when the population size is not known, or we call it as infinite population. And the other scenario is where the population size is known, which is a finite population. The following are the formula used for sample size estimation in both the conditions. In the formulas, Z stands for the corresponding values of confidence level. Sigma stands for the population standard deviation. Small letter e stands for margin of error or confidence interval. Capital N stands for the population size. And small n0 stands for the sample size estimated for infinite population. Again, a few more important points to be given special attention. Here I have given the Z values for the commonly used confidence levels such as 90%, 95%, and 99%. Z values can be read from the Z tables. Another important point. Since we have not conducted the study yet, how can we get the population standard deviation? A few commonly used strategies are finding the population standard deviation from the previous researches done with the same population, or finding this value through a pilot study, or the most commonly used value is 0.5, which is the maximum standard deviation possible. Finally, the commonly used confidence interval is 5%, which is equal to 0.05. Now you have all the values. Just plug in these values to the formula and you can estimate the sample size. Here I have given a few examples